discuss about the what is called as that one is the significance of the Hessler's, why they are using the Hessler chart, that one is. And also we discussed that one is the what is the thermocouple. That one is thermocouple is used to measure the temperature and response of the thermocouples and sensitivity of the thermocouples. That one is the why they are using a smaller diameter of the wire, okay, material in the thermocouple. That one is the because due to give the good response, immediate response. That one is the so that one is the that's term HAS divided by rho V into C. We discuss about that one is okay.
Okay, sir.
Yeah. Then the question is that a transient heat conduction, if the Biot number is tends to infinity, okay, H or Biot number. Understand? Transient heat conduction in the semi-finite solid. Understand? Semi-finite solid. If the Biot number is that one is the tends to infinity. That one is so. In that case, how to solve that one is, and this is the theory only. That one is understand. They will not ask any theory only. That one is it don't have any derivations. That one is okay. So this is the only theory. You need to understand this theory, and based on this one is if they want to ask anything, that one is only they will ask the numericals, and that's the numericals is only about the 3 to 4 steps. That one is then how you are. That one is the look into the data handbook. That one is depending upon that one is a very that one is. This semi-infinite solid. Okay, so I will give an example of the semi-infinite solid. That one is. All of you know about that one is the pipes are used to carry the what is called as a steam. So that pipe is are in the underground. That one is. All of you okay? Pipe are in the underground. That one is. So if the pipe are in the underground, that one is, then how to calculate the transient heat conductions. That one is. How to measure the temperature if the solids in the underground or in the beneath of the ground. That one is. So you need to discuss about that one is. Okay. So that is called as a transient heat conduction in semi-infinite solid H, or that one is the and B Biot number tends to infinity. Then not only pipe, that one is any object which are buried under the at a certain depth of the distance. Okay, so in the earth, so that one is the how distance the transient heat conduction will be taking place at this. We need to discuss about that. Okay, here. Here, the sun is a solid here. Okay. So
Yes,
here the infinite solid. So the sun is here. I taken each and everything. Okay. I taken each and everything according to the data handbook. That one is. So that is called as an infinite. What is the meaning of the infinite solid? A solid which extend itself infinitely in all direction of space termed as an infinite solid. Understand? A solid which extend its thickness in x direction, y direction, and z direction, means in all direction of the space, is termed as an infinite solid. That is. Understand? So this T naught is called as a surface temperature. So semi-infinite product. So we call and a Ti is called as a initial temperature. This is called as a Ti. Ti is called as the initial temperature. And so this solid material through which conduction will be taking place. That is a conduction is equal to minus Ka dt divided by dx. This is at x is equal to 0. This is at x is equal to infinity because it is called as an infinite. That one is. Okay. Suppose if it is an infinite solid is there, infinite solid can split at mid-plane. Understand? If they can split or cut into the mid-plane, each half is known as a semi-infinite body, or that's called as a body. If the infinite solid is there, okay, cut into this, so cut into the half, okay, so cut into the two pieces. that becomes the what is called as a semi-infinite solid, that one is. Understand? Semi-infinite solid, that one is. So in a semi-infinite solid, suppose if it is a semi-infinite solid, that one is, temperature at any point of the a semi-infinite solid, that one is, means that one is, so we cannot melt. We cannot melt. So whether it's a cooling process is there, whether the hot, so that one is the hot heating process is there. So temperature is unaltered at any surface at any point of the semi-infinite solid, that one is. Understand? Because of infinite length. Understand? If it is in the heating or cooling, the temperature at the surface, okay, anywhere at the point of the surface, okay, it is, that one is the, we cannot melt, that one is, because of the so semi-infinite plate, that one is. Understand? That's why the semi-infinite plate solid at any instant of time, at any instant of time, there is always a point where the effect of heating or cooling at one of its boundaries is not felt at all. Understand? At any point, okay, at any point, that is, so the heating or cooling process, that is, the temperature changes will not felt at all. Understand? Because of this one is the semi-infinite plate here, that is. Understand? If the length, I think we discuss about that one is, if the length is more, understand? If in case of the pin or in case of the anything, that one is material, that one is at the boundary, that one is. So sometimes cases, that one is at the boundary, temperature of at the boundary is also equal to the what is called as the temperature of the surroundings, that one is. Understand? In the pin also we discussed, that is called as in the long pin pattern. That's why in the semi-infinite solid, at any instant of time, at any time, there is always a point where, always a point means at the boundary only. Always at a point means a boundary where the effect of heating or cooling at one of its boundaries is not felt at all. So at that point, temperature remains unaltered. At any point of the boundary, temperature remains unaltered, that one is. Understand? So a transient temperature, we are calculating a transient temperature. That is how it's the temperature of the infinite solid, where you will take time. A transient temperature change in the infinitely thick wall is similar to that of the semi-infinite body until enough time required. The temperature. So what is the transient heat conduction? Means temperature change. So that means if you want to change the temperature, sometimes is required. Understand? Okay. So even if in the semi-infinite solid, that one is, so temperature is remains unaltered, that one is, but it's sometimes required to change minimum changes also, that one is. Understand? Sometimes it's required. So that is the meaning of this one is a transient temperature change in the infinitely thick wall is similar to that of the semi-infinite body until the enough time is required, that one is. Understand? Okay. So it required some time to change the a small amount of temperature at the boundary. So because of the temperature is varying with the time, that one is. Understand? So that is the meaning of that one is. Okay. So considering the semi-infinite plates, this is called as a semi-infinite plate, where T naught is called as a surface temperature, Ti is called as a initial uniform temperature of the body, semi-infinite body, that one is. Understand? Okay. So x is equal to 0, x is equal to infinity only in the positive x direction, certain is. Understand? Here x is equal to 0, x is equal to infinity only in the positive x direction, that one is. So body Ti is called as the initial temperature, understand? And Ti is called as the initial temperature at x is equal to 0, including the surface. Understand? Including the surface. So that's what is the including the surface. This Ti is suddenly raised to the T naught. This Ti is suddenly raised to T naught for all times greater than T is equal to 0. Understand? What is small t? Small t is called as the time. Understand? So initial temperature at x is equal to 0, t is equal to 0. Understand? But initial temperature raised to T naught. Understand? Raised to T naught for all the times greater than when the temperature, that means the time, is equal to 0. Greater than T is equal to 0. Means that is the 1 second, 2 seconds, or 3 seconds, or 4 seconds, like that means. Okay? So the governing equation for this one is, already you know that one is the governing equation, because d square t divided by dx square is equal to 1 upon alpha d capital T divided by d small t. So this one is called as so why you are taking d square t divided by dx square, because it is varies in the positive x direction only. We are taking in the positive x direction only. The boundary conditions here they given, that one is, understand, boundary conditions here they given T of x is equal to 0, then T temperature is equal to Ti. Understand? So T at x is equal to 0, the temperature is equal to initial temperature. Understand? T, so x is equal to 0 at a time, okay, at a some time, that is equal to T naught when T greater than 0, time is greater than 0. Understand? Then when T that stands to infinity, x stands to, okay, x is equal to infinity, x coordinate infinity, and it's a certain time, that one is, okay, time. So that's also T equal to Ti, initial temperature, when T greater than is equal to 0, that one is. Why you taking that one is the, what is called as the T when x tends to infinity, means that one is whether the cooling process or heating process, that the boundary, so okay, at any point the temperature will not changes, will not alter, that one is, understand, because of the infinite thickness, that one is. So that is the meaning of this one is, understand. So these are the boundary conditions, and this is the governing equations, that one is. The solution for the differential equations 1, substituting the boundary conditions for the temperature division at any time t at a plane parallel to and at a distance x from the surface is given by, so this is called as a equation, final equation system is, okay. This equation is very important, that one, Tx of t minus T naught divided by Ti minus T naught is equal to ERFZ, or ERF is into x divided by 2 root of alpha t here, that one is. This is the z value. ERF means that is called as a error function. Error function. ERF is nothing but that one is the error function of z. Error function of that one is x. This is called as a z, where ERFX divided by 2 root of alpha t is known as a Gaussian error function, that one is, understand, Gaussian error function, that one is, okay. So this is the solution, that one is, okay. But you should know this equation. So T of xt minus T naught, okay, this is called as a surface temperature, okay. This is the temperature at any value of x at and t, okay. So temperature at any value of x and t, and Ti is called as the initial temperature. This equation is also available in the data handbook, that one is, okay. So I will show here that one is the how it is available, that in the data handbook, that one is today. So this is called as the, what is called as a data handbook. T of x minus T naught divided by Ti minus T naught ERF x divided by 2 root of alpha t. Understand? Surface temperature suddenly changed and maintained at a constant. So here they given that one is a, what is the Ti and what is the T naught, that one is, understand. So you calculate the temperature at any depth of x or at any time t here, that one is, and also you calculate the heat fluxus. This small q naught is the heat fluxus, that one is, understand. So this is the important equations, that one is, understand. This is the, what is called as, this equation is called as the important, that one is, understand. So do you have any doubt here, that one is? Okay. Do you have any doubt here? Because this is a semi-infinite. Once again, I'm so explaining about this one is uh, this is a T naught is called as a surface temperature and Ti is called as a initial temperature. This is the infinite. Initially, it is a infinite wall or infinite plate. That one is, if it is infinite plate cut into the two section, that one is, that becomes the semi-infinite plate. That one is okay. So temperature at any condition, at any point of the boundary, so will not alter. Understand, whether it may be cooling or it may be a heating process because of the a longer thickness. Understand, longer thickness that one is. So this one is temperature is not alter. That one is okay. Even if it is a alter, that one is a small amount of time it will be taking. That one is called as a transient temperature. That one is, or unconditional unsteady state temperature. That one is. Understand. Okay. So here the temperature we are taking, that one is the only in x direction. Understand, x direction. Okay. So temperature changes only in the x direction. Certain is then. So this equation, governing equation is that one is the d square t divided by, so this one is the d square t divided by dx square. This is equal to 1 upon alpha d of t divided by. So this is a boundary condition. Certain is, you have to substitute this boundary conditions into this one is, you will get the a final equation, that is dt of x of t. So x comma t minus t infinity ti minus t infinity is equal to erf z. So erf is nothing but that one is called as a error function of z. So this is called as a z value. That one is okay. So that one is the, so erf so is known as a Gaussian error function. So we can also calculate. So this is the equation. Okay. So 2 divided by root upon 5. So this one is the 0 to z e raised to minus m square into dn. But you should remember this equation, or you can also note down. This one is available in the data handbook. That one is. Understand. Okay. So we'll solve that one is. So generally they will ask the numericals. They don't ask any the definitions of all these things that one is, and but you should know how to solve the problem. That one is. Understand. Okay, we'll go for this one is one numerical. A steel ingot is called as nothing but that one is the casting part. A steel ingot, remember that one is the a material here. That one material is called as a steel ingot, large in size, heated uniformly to 745 degrees Celsius, is hardened by quenching it in oil bath maintained at 20 degrees Celsius. Understand? So what is this 20 degrees Celsius? Means that is the, if the steel ingot is there, that is in the oil bath, then surrounding fluid temperature is called as at 20 degrees Celsius. So this is also called as a surface temperature. So we treat this one as a surface temperature. T naught is equal to 20 degrees Celsius here. Determine the length of time required. T, length of time required. Determine the length of time required for the temperature to reach the 595 degrees Celsius. What is a 595 degrees Celsius? Here that one is the Tx minus, this is a, you can note down this one. We can note down this one is from the data handbook. Tx minus, okay. So Tx minus that one is minus T naught, Ti minus T naught, where that one is T naught is already taken, that one is a 20 degrees Celsius, and Tx is called as a 595 degrees Celsius. That one is. Determine the length of time required for the temperature to reach the 595 degrees Celsius at a depth of 12 mm. What is the x here? X is equal to 12 mm. Understand? X is equal to at the depth of 12 mm. The ingot may be approximated as a flat plate. Ingot. What is the shape of the ingot is? That is a flat plate. So this is the case of that one is the, here that doesn't given any thickness. Okay. So given that one is any dimensions of the steel ingot? No. So that one is the here by looking into this problem for the ingot, take is equal to alpha is equal to 1.2 into 10 raised to minus 5 meters square per second. That one is understand. So this is the case of semi-infinite solid. The ingot may be approximated so as a flat plate. This is the case of the semi-infinite solid. That one is understand. So how to calculate? So the one is here there doesn't given any dimension of the steel ingot. That one is. So this is the case of the semi-infinite solid. That one is. But we need to, this x is given. We need to calculate that one is called as what is called as the temperature at the 12 mm. Understand? So this 595 substitute all these things that one is there. So that one is the 595 minus 20 divided by 745 minus 20 is equal to ERF x divided by 2 root upon 1.2 into 10 raised to minus into t. Time is there. Then 0.79. So you have the one is 595 minus 20 divided by 745 minus 20, 0.79 ERF 0.112. Okay, x is there. We need to calculate t. Understand? So here, so we have to look into the table. So ERF Z, this is this term. Understand? This term is called as a Z. So this is total. It is called as a ERF Z, error function Z. So if the error function Z is equal to 0.79, then what will be the Z value? Understand? We need to. Suppose that error function, error. So look, you see here that is 0.79 is error function of the Z. Come to the table here. Error function of Z. Okay, can you get this one? Hello? Hello, Ajit? Hello? 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 All of you, can you get this values of the error function?
Yes, sir.
Yes, sir.
Yes, yes, yes.
Sir.
Yes, sir.
Yes. Error function of Z. Error function of Z is 0.79. Look at here, that one is. So here, that error function of Z is equal to 79 here. Okay. Here getting that one is a 79. 79691, that one is. Okay. So it will get that one is what is called as the Z value. So here that one is the first one is the Z value and is AR of Z. So ERF Z is equal to 0.79. Understand? 0.79184 for that one is a 0.79691. So you can take 0.89 or Z value 0.89 or 0.90, that one is. Okay. Come to here, that one is called as here that one is the, so I taken this one is the value of this one is the 0.79. Understand? So okay, so here the 0.79, so 0.79, then ERFZ is equal to 0.79, then Z is equal to, because x divided by root upon alpha t is equal to 2 into root upon alpha t is equal to Z. Z value is equal to 0.9 here, that one is, understand? So then, you get that one is the a value here, that one is, then you can calculate the, what is called as the T is equal to 3.7 seconds here, that one is. Substitute the values of the X here, substitute the values of the alpha T here, and this is called as a Z value. So you can note down the table, okay? Table is there. So ER of Z value is 0.79 here, 0.79, okay? And Z value is 0.90. From that table from the data handbook, you will get that one is, so we will take that one is Z value here. Then what is the T value? T value is equal to that one is you will get that one is 3.7 seconds, that one is, understand? Means that for the depth of the 12 mm to the temperature reached to from 745 degrees Celsius to 595 degrees Celsius, the time it will take is called as the 3.7 seconds, that one is. Okay. So then, okay, we'll solve the next, that one is the, what is called as the next one. So I given that one is the, what is the applications of the semi-infinite, that one is, understand? Semi-infinite. So water pipes, understand? Steam which carries, that one is the pipes, and which is buried underneath of the ground, that one is the, then so we can treat that one as the semi-infinite body, that one is. Then how to calculate the temperature at some depth and what is the time required for that one is, understand? So this is the, we can solve this one is the type of the problems here, that one is. Water pipes are to be buried, so buried underground in a wet soil, in the wet soil. So where that one is the thermal diffusivity of that one is so that one is the 2.78 into 10 raised to minus meter square per hour. Understand? You have to make it the point here, meter square per hour, which is initially at 4.5 degrees Celsius. Okay, that one is the water pipes are to be buried underground in a wet soil, which is initially TI is given, that one is the 4.5 degrees Celsius. The soil surface temperature suddenly drops to minus 5 degrees Celsius. Understand? The soil surface temperature suddenly drops to, or soil surface temperature suddenly drops to minus 5 degrees Celsius and remain at this value for 10 hours. Time is given, that one is remain this value minus 5 degrees Celsius will be remain up to 10 hours, that one is. Calculate the minimum depth, okay, at which the pipes are laid, pipes are buried, if the surrounding soil temperature is to be maintained above 0 degrees Celsius. If I want to maintain the above 0 degrees Celsius surface temperature, understand? Because it's already dropped to minus 5 degrees Celsius, understand? So soil surface temperature suddenly drops to minus 5 degrees Celsius and remain at this value for 10 hours. Calculate the minimum depth, X you need to calculate minimum depth at which the pipes are laid if the surrounding soil temperature is to be maintained above 0 degrees Celsius. If I want to maintain the, what is called as a 0 degrees Celsius, so minimum depth, what is the minimum depth? So we need to bury the pipe, we need to calculate that. Understand? The soil may be considered as a semi-infinite solid. Understand? The soil may be considered as semi-infinite solid, that one is. Understand? Treat the present conditions as the conditions of the semi-infinite solid. Treat the, so directly they given that one is they treat the present conditions as the conditions of the semi-infinite solid, that one is. Understand? Means that one is the water pipes, understand, water pipes, they has to buried underneath of the ground, that one is. The initial temperature of the water pipe is called as a 4.5 degrees Celsius and suddenly soil surface temperatures drops to minus 5 degrees Celsius. This minus 5 degrees Celsius remains for 10 hours that is if I want to maintain the 0 degree Celsius of the surface, okay? So this 0 degree Celsius, what is the minimum depth at which pipes are buried? How much, at what depth I need to build the pipe pattern is. You need to calculate that one is. Understand? Okay. So this is the, so we have to treat this one is the semi-infinite solid that one is. Understand? So that's one is the given data is called as the Ti is equal to 4.5 degrees Celsius. T naught is equal to minus 5 degrees Celsius because of the surface temperature drop to minus 5 degrees Celsius, and T is equal to 0 degree Celsius. We have to maintain the 0 degree Celsius. Okay. We want to maintain the 0 degree Celsius. Then alpha is equal to 2.75 into 10 raised to minus 3 meters square per hour. So you have to keep it is in the meter square per hour only. I calculated in the meter square per second. So, but you need to keep in the meter square per hour because time is given in the 10 hours only. Understand? The T is given in the 10 hours. Then we need to calculate at what is the depth we need to build the pipe that one is to maintain the a surface temperature that is called as a 0 degree Celsius. We know that equation that is from the data handbook. You know to know about that is Tx minus T naught divided by Ti minus T infinity. That is equal to ERF, error function, x divided by 2 of root alpha into T here. What is the surface? That one is the we need to maintain that one is 0 degree Celsius. We need to maintain that one is. What is the T naught here? T naught is equal to minus surface temperature. Surface temperature drop is equal to minus 5 degrees Celsius. So 0 minus of minus 5 divided by what is the initial temperature? 4.5 degrees Celsius minus of. So this one is the T naught here minus 5 here. So that becomes the to pi divided by what is called as so 9.5. Okay, pi divided by 9.5, that is equal to 0.5263 here. That one is, understand, 0.5263 here. That one is, so 0.526 is equal to ERF. So x divided by 2 root upon alpha T. That one is, understand. Suppose ERFZ, this is x divided by root upon, so the one is 2 root upon alpha T. This is called as a Z value. ERFZ is equal to 0.526. Then Z value becomes that one is the 0.5 here. Understand? From the table, okay? You can note down from this table that one is. Understand? When ERFZ is equal to 0.52, so this one here. 0.52, understand? So here that one is 0.5294 here they get on is, that one is there. So Z value is called as a 0.1, understand? 0.1 here that one is. So we are taking from this table here that one is. Then so we take here that one is the 0.5 value here that one is. Note on the correct values from the data handbook and you have to note on that list. So then x divided by what is called as 2 root upon alpha T is equal to 0.5. That is a Z value. Because this is called as a Z value, then x is equal to 0.5 into 2 root upon 2 into, so root upon 2.78 into 10 raised to minus 3 into 10. 10 is called as a time. Then x is equal to 0.162 meter. Okay. So at this, okay, at this depth, we need to build the what is called as a pipe to maintain the surface temperature 0 degree Celsius. Understand? So this is the concept of this numerical that one is. Understand? Okay. So that one is the, this is the how to solve that one is the that one is the problems when the infinite solid. Okay. So treat as a semi-infinite solid, that one is the problems that one is how to solve that one is. So you should know this what is called as this equation from the data handbook, and you should know that one is how to look into the table. That one is, that's very easy. That one is from the table. Okay. So then So this is the how to calculate the time and how to calculate the at what depth we need to build the a solid, that one is understand. So that one is the, I think the page number 59 and 50, what is called as a 60. So you will get this table, that one is understand. The formula you will get in the page number what is called as a 59 of the data handbook, and what is called as a data, that one is the table, we get the page number 60. I think that one is, if it's the new book, it will be vary, the page number will be. So based on this, we need to calculate the heat flux also. Understand? So what is the material, what I sent, that one is, so I sum in the sum of problems, I calculated that one is the heat flux also, that one is. So you need to know about that one is the, what is the heat flux here, that one is. Okay. So that one is the, so here the transient heat conductions theory and different types of the numericals I solved, that one is. Do you have any questions in this? You